Okay, so let's try to go some of these differentiation by rules examples. Again, if you can, try and stay one step ahead. So pause and try and stay ahead of me. And I'm going to stop this video after 10 minutes. So whatever I get through in 10 minutes, I'll stop. And if I need to do another video, I will. So let's go. This first one here. So this is the first example that I see that I come across. This is just, I think it should be okay with everyone. It's just differentiation by rules. So it's going to be 4x cubed plus 6x squared. 4 squared. Well, maybe I meant to put maybe an x in there. Maybe I'll add it in a bit, but everything else is just nothing, just plus 0. Don't need to put it in. So that's that one derived. This one here, again 1 over bit. You can either use the quotient rule or write this as x squared minus 35 x plus 4 to the power of minus 1. Okay, that's probably how I'll go like that, and then use my my product rule there for that, which is for this the chain rule. So it's du dv times by dv dx. So the inside outside rule. So derive what's at the outside first. So that will give us minus 1 times by everything inside the brackets. Just leave that alone. X squared minus 35x plus 4. So just leave that alone. Reduce down to power by 1, so to the power of minus 2, times by what's inside. So derive this bit now. So it's going to be 2x minus 35. So that would be that derived. That's all you really do with that. It's fine as is like that. Again, if you want to maybe change, so leave the minus 1 out here for a second. You might see this written then. So this could be written as 1 over x squared minus 35x plus 4 to be squared. So then the overall thing could be written as just minus 2x minus 35 over x squared minus 35x plus 4. So again, just it could be written in this form here, but more than likely in that form there. Is that okay? So that would be that second one done. Let's stay going while we're going well. This one here. So what should jump out for me here is that this is 2 separate functions getting multiplied together. So you have one function times this second function here. And if you see 2 functions multiplied by the other, label one u, one v, and it's going to be the quotient rule, or sorry, the product rule. So the multiple of 2 things, and that's the formula for that is u dv dx plus v du dx. So my u is given, so my du dx is going to be just 1, and my dv dx is going to be just deriving what's in the red there, 8x minus 2. So now let's try and apply this formula to it. So it's going to be u is x plus 3, and dv dx is times 8x minus 2 plus v is that long one, so 4x squared minus 2x minus 3 times by du dx just times by 1. That would be that done. You could expand that out and tidy it up, I guess. I'm not going to go through that now, but you could. Now we're on to some trigonometric ones, so lovely timing for these. And with these, we have to derive technically the chain rule, but we derive what's inside first of all. So the angle, in this case, it's going to be the derivative of that is 2, and now we derive the overall thing. So 2 times by 310 becomes sec squared, and whatever the angle is, 2x. So this would be 6 sec squared 2x. That would be how you derive that, okay? And again, there's a button on your calculator for a sec. Okay, moving on down to the next one. So this one here is 5 times sine of 3x plus, sine, 5 times sine x plus 3. Well, just 5 is just a number, so that's just a coefficient. The same thing, 5 sine x plus 3, okay? So it's the same thing. Derive what's inside. That'll leave me at 1 times by the derivative of, so 5 times the derivative of sine is cos. And the angle will be the same always, okay? So x plus 3. You need to expand the brackets just to get rid of the 1 there, but I think that's okay. On to the next one. So actually this is a nice two to link up with. So this one here and this one here are very different for one particular reason. It's that there's an x here. So the 5x times sine x plus 3. Well, I need us to understand that if there's an x here, if there's a variable, then this is a function by itself. So the addition of the x there means it's its own function. Trying to keep my brackets nice and tidy. So it's 5x is the first function, that's u, and this is v here. So it's a product rule of u dv dx plus v du dx. Okay, so we have to make a product rule out of this with the, because it's two separate functions getting multiplied together. So we have our u, we have our v, du dx in this case is 5, dv dx in this case is so sine becomes cos, so it's just, and derive what's inside here, so it's 1 cos x plus 3. Okay, we'll try and apply all that back in then. So there'll be a little bit of stuff here. So it's 5x, that's my u. dv dx is cos x plus 3 plus v, which is sine x plus 3 times by du dx, which is times by 5. Okay, and that's how you'd write that one there. That's the derivative of that function. Okay, so again, it's important for you to spot that the difference there between having an x on the top, having an x there after the 5 and having no x. Okay, the x there means it is a function of its own function. Moving on down, so we'll try and get through this page, and that might stop the video then. This one here, well, it should stand out as a very obvious chain rule function where it's inside outside bit. So deriving the outside, so that's just like the 4 with the coefficient before everything, so that's just 4 brackets 6x squared plus 4x plus e to the power of 3, so that's that bit derived, and that gets times by the derivative of what's inside in the brackets. Let's use a different color. So, and then the derivative of this is, well, 6x squared will become 12x, 4x will just become plus 4, and e is just a ratio or a number value, and that just that would derive to 0, so there's no need to put that in. Okay, and that's it. You wouldn't go expanding that much further than that. That's perfect as it is. Bar you were asked for it in a different form, but you shouldn't be. Okay, and here we should see that this is, again, go back here, two separate functions, label them up as u and v. So I hope you can spot why they're different functions. If not, just come back to me and I can go through that with you. Actually, and what we should look out for here as well is shortcuts. Okay, so that definitely is a product rule. The product rule would fix that because it's the same angle here, and look out for the same angle. So this 4x with both of them have a look through your log tables and see if there's any way that you could rewrite this using trigonometry. And I can see here that I have on page 14 on your log tables, there's 2 sine A cos A can be written as sine 2 of whatever the angle is. So this that's in your log table. So trying to apply this to this question, we could, I guess, write this as sine 2 times 4x or sine 8x. Okay, and just derive that as one single function now. That should be the same thing. Okay, and that's just following log tables again. This sine 8x should be okay, going back from the examples that we've just done. Okay, I'm going to stop that up there now. And again, sorry, yeah, so before I stop it, just do look out for that. If there's ever a case where it's the same angle in trigonometry, they're kind of hinting at you that maybe you can simplify it down using the log tables. Okay. Yeah, good stuff.